In this tutorial, we'll cover some essential Docker commands. Before you begin, make sure you have created a Docker Hub account. And you have Docker installed on your machine. In this section we will learn about Docker image-related commands. Open your terminal and follow along to gain confidence. Ensure Docker is installed by running the docker command. You can check if you're logged in by using docker login with your Docker Hub account credentials. First command that we will learn is to pull Docker images. The docker pull command is used to fetch images from a registry. Let's search for the Hello World image on Docker Hub and pull it with a specific tag. Let's use the Linux tag. Command is docker pull followed by image name : image tag. If no tag is provided, it will fetch the image with the latest tag. The second command we will learn is to list images. You can list the images available on your machine using the docker images command. This will show the Hello World image with the Linux tag that we pulled. Now let's learn command for building custom Docker images. To build a Docker image, you need a Docker file, which defines the instructions for building the image. In our case, we have a sample Python app with a Docker file. It's a simple Python app that will print Hello World. And if we look at the Docker file, it contains instructions to use the official Python 3.9 Slim image as the base. Set the working directory to /app in the container. Copy the app.py Python script to the container. Specify that the Python script should be executed with python app.py when the container runs. Now, let's build the Docker image and assign a tag. Docker build -t myimage test. Where -t is to specify tag you want to assign to the image. The period at the end tells Docker to look for a Docker file in the current directory. Build is complete, now we will list the images. We see myimage with tag test is created. Next we will learn docker command to remove Docker image. If you want to remove a Docker image from your local machine, use the docker-rmi command, followed by the image name and tag. So the command is docker-rmi myimage test. The image will be untagged and deleted. After running Docker images, you won't see it listed. Here's the summary of Docker image commands, and you've learned the essential commands to pull, build, list and remove Docker images. In this section, we will explore commands for managing Docker containers. Let's start by listing the Docker images available on your local machine. Now, let's run a Prometheus container. You can pull the image as we've previously learned. To start the container, use docker run followed by image name : image tag. The Prometheus container started running, but it is running in the foreground. You can stop it by pressing Ctrl+C. To restart it in the background, use the -d option, which runs the container in detached mode. Docker run followed by -d followed by image name : image tag. To list all the running containers, execute docker ps command. You'll see the Prometheus container which are running. If you want to list all containers, including the stopped ones, use docker ps followed by -. We can see running as well as exited or stopped containers. Now to stop a running container, you can use docker stop followed by container name. Once stopped, it won't appear in the list of running containers. Now to start a stopped container, you can use docker start followed by container name. After starting, it will reappear in the list of running containers. To execute commands within a running container, you can use the command docker exec-it followed by container name followed by bash. If bash is not within the path of container, we can use sh and retry. Here -it indicates interactive mode and sh to run a shell program. This will place you inside the container. To exit the container, simply type exit and press enter. Now to remove a stopped container, use the command docker rm followed by container id. The container will no longer appear in the list of stopped containers, as it's been removed. So in this section we learned essential Docker container commands for managing, starting, stopping, and interacting with containers. In this section, we'll explore Docker commands related to container networking and port management. To see a list of available Docker networks, use the command docker network ls. This command provides information about the networks on your Docker setup. To create a new Docker network, use the docker network create command. For example, docker network create followed by network name say my test network. This command creates a network name my test network, which can be used to connect containers. On listing the networks again, we can see my test network is created. You can connect and disconnect containers to from networks using the commands docker network connect followed by network name which is followed by container name. This allows the specified container to join the network. To disconnect a container from a network run docker network disconnect network name followed by container name. This removes the container from the network. Next, to see the ports mapped by a running container, use the docker port command. But we need a container on which port mapping is done. We will run Prometheus image and map its container port 9090 to host port 9091. Using the -p option in docker run command we can map container port to host port. Now we will run docker port followed by container name command. This command displays the port mappings for the specified container. That concludes our overview of Docker commands for managing container networking and ports. You can use these commands to list, create, connect, disconnect, and inspect the networking configuration of your Docker containers. In this section, we'll explore Docker Compose, a tool for defining and running multi-container Docker applications. Docker Compose simplifies the process of managing complex applications consisting of multiple services. Docker Compose is a tool that allows you to define and run multi-container Docker applications using a configuration file called docker-compose.yml. This file describes the services, networks, and volumes required for your application, making it easy to manage complex setups. Docker-compose up is the command to start the services defined in your docker-compose.yml. This command reads your configuration, creates and starts the necessary containers, networks, and volumes. We can see images for database and web app services as defined in docker-compose file are getting pulled. We can see containers Docker, Database 1 and Docker, Web App 1 are running. Also we can see Postgres and Nginx image which were defined in docker-compose file are pulled. We can see volume by the name docker_db_data is created. Also network by the name docker_default is created. Now we will check the networking of two containers by getting inside one container and trying to reach other. Let's exec into Docker, Web App 1 container. Let's see if we can ping Docker, Database 1 container from Web App container. For ping command not found error, we will install ping using apt-get. We will retry reaching database container using ping. Zero packer loss, which means web app container is able to talk to database container. Run exit to come out of the web app container. Docker-compose down is the command used to stop and remove the services defined in your docker-compose.yml file. This command halts and removes the containers, networks, and volumes, effectively stopping your application. Docker-compose simplifies the process of managing complex applications by allowing you to define, start, and stop services with a single set of commands. It's a valuable tool for orchestrating multi-container applications with ease. In this section, we'll delve into Docker volume commands, which are essential for managing data in containers. Docker volumes are used to persist data between container runs. To create a new Docker volume, use command docker volume create followed by volume name. This command creates a volume named myTestVolume that can be attached to containers to store and share data. To see a list of available Docker volumes, you can use the command docker volume ls. This command provides information about the volumes on your Docker setup, including their names. If you want to remove a Docker volume that is no longer needed, use the command docker volume rm followed by volume name. This frees up storage space and ensures that the volume is no longer available for containers. One of the key uses of Docker volumes is to mount them within containers to provide a shared storage location. This is often done in container run commands using the -v or --volume option. For example, docker run -v myTestVolume:/tmp. This command mounts the volume at the path/tmp inside the container, allowing data to be shared and persisted between containers. Let's check if the data is persisted even if the container is stopped or removed and recreated. For this we will get into a container. Go to the /tmp directory. Create a test file. And come out of the container. Let's stop the same container and then remove it. We see the container is deleted. Now let's create a container again by attaching the same volume, which is my test volume. Once the new container is created, let's exec into it and go to the mount directory, which is /tmp, and check if the test file is present. We see the test file is present, hence the data is persisted. Docker volumes play a crucial role in managing data for containers, and these commands allow you to create, list, and remove volumes as well as attach them to containers for data sharing. In this section, we'll explore Docker registries and the essential commands for tagging and pushing Docker images to registries. Before you can push or pull images from a Docker registry, you need to authenticate. To log into a Docker registry, use the command docker login. This command prompts you to enter your Docker Hub or private registry credentials, username and password. Once authenticated, you can perform image push and pull operations. First, we will change the name of our image to be pushed such that it has the registry and repository name. Docker tag is a command used to assign a new name and optionally a new tag to an existing Docker image. We will use the command docker tag source image tag followed by target image tag. The new image name should be such that it have information about registry, repository, and tag. We will sign into our Docker Hub account from UI and copy the registry name, which is Docker 2023. Add a slash and then paste the repository name, which is myimage, and then add a tag. Let's tag it as 2. We see creates a new image with the new name based on the original image. The new image has the same content but a different name. Now let's upload or push a Docker image to a registry using docker push command followed by new image name. Now let's go to our registry on Docker Hub and see if the image is pushed. We can see a repository by the name myimage is created a few seconds ago. And the image with tag 2, same as what we have defined, is present in the repository. Now we are familiar with docker login, docker tag, docker push and docker logout commands. In this section, we'll dive into container logs, a crucial aspect of managing Docker containers, and introduce the fundamentals of container monitoring and resource management. Docker provides a convenient way to access container logs using the docker logs command. The basic syntax is, Docker logs container name or ID. We can see the container logs as the output. This is incredibly valuable for troubleshooting, debugging, and monitoring your containers, helping you understand what's happening inside them. Thanks for watching. Subscribe for more content.